Hi, my name is David Busacker, and I'm a consultant here at Stratasys, and I'm going to talk to you a little bit about inspection fixtures. Some of the biggest pain points when it comes to assembling inspection fixtures traditionally is the tolerances that can stack up when doing assemblies. In addition, it can be very expensive to machine all the parts required to make the jigs. With 3D printing inspection fixtures, you can eliminate the added costs and unpredictability of assembly, along with the lead times that are associated with multiple manufacturing methods. So for example, with this inspection fixture here, there are several traditionally manufactured pieces that all have to be manually assembled after the fact. With 3D printing, we can digitally consolidate the assembly so that there aren't any unknowns when we create the part. Auric is one of the examples of our customers that's using 3D printing for inspection fixturing. Traditionally, they were using urethane casting for their production of inspection fixturing, but once they started using 3D printing, they started making some serious resource gains, including 50% of the production time of the actual fixture, 29 times faster inspection speed actually performing the inspections, and up to 80% cost savings overall once they actually had produced the fixtures. Accuracy is a priority when it comes to inspection fixtures because inspection is all about accuracy. Stratasys FDM printers are known for their reliability and dimensional accuracy, especially the 380 and the 450. Depending on what the application is, the material might differ. So for instance, for a low-end application, ASA might be an appropriate material. If there's higher requirements on the inspection fixture, something like a polycarbonate like you see here might be more appropriate. But depending on the application, Stratasys FDM printers have a wide variety of solutions available. GrabCAD print software speaks to the entire family of Stratasys 3D printers. It eases the workflow from CAD design to data preparation to print, and it also allows you to watch prints before they've begun printing, while they're printing, and to see whether they've finished or not. To recap, Stratasys 3D printers won't just save time and money in the inspection fixture production process, they might even be the most accurate way of creating them.
The America's Cup is the oldest competition in international sports history. It started in 1851 as the Guinea Cup. The America's Cup is named after the first yacht to win the America and was a trophy that was put in trust to the New York Yacht Club. The America's Cup, for me as a sailor, is what I was born to do. It's a unique game in that all your eggs are in one basket.
The boat's able to create enough power to get up out of the water, reduce the drag of the hull and go up into the foils, and with that comes more and more speed. The next thing you know, the boat's doing 40 knots. Pretty exciting.
The car that won this year's Indianapolis 500 had the most 3D printed parts on it. It's clear where we have to go.
Working with Stratasys gives us a competitive advantage because of the quick turnaround.
The boat will come in at the end of the day, and then the sailors and the engineers really work to develop the next piece of equipment for the next day on the water.
I can have someone come to me with something that we need for the boat. They'll tell me what is needed from the part. I'll CAD it that afternoon, put it on the printer for overnight, and hand them the piece in the morning.
This part we 3D printed. It's a fairing for where the bobstay, which supports the bowsprit, goes in, meets the hull. And so we just needed a fairing to fill the cavity in the boat.
So this piece clips on both sides, screws top and bottom, and then slides down into that cavity to fair the hull.
The machine was able to print this overnight, whereas traditionally this would have been a 2-day process for a guy to actually construct.
What I look for in materials first most is weight, because our boat has to be a specific weight. It cannot be heavier than X. Any gram that we might be able to remove from another component, we can add a system that will give us knots of boat speed faster when we're racing. Our second constraint is strength. So I can't say anything about the materials I use from Stratasys' tool set, but I have not had any issues finding a strong enough material for all of our applications.
We're in a competition of design. The fastest boat's going to win the regatta, and having everything be perfect is critical to the development of the boat. From every little detail, we do the 3D printing prior to it going into the yacht, and that way they can make sure the assembly of it is bang on.
A factor that helps us a lot working with Stratasys printers is their precision. So I can CAD a piece to be a certain diameter and it will be that diameter. So I don't have to iterate on simple things like fit or piece size. I don't have to add a tolerance, test the tolerance, add another tolerance, test a tolerance. I can CAD a fit and that will be that part. I don't have to be on site next to the printer. I can be next to the boat, wherever the boat may be. So I will often CAD a part, turn it into a printing file, and send it to the printer remotely.
For me, when I'm eating dinner at night and I'm watching all the video of the day, and it's like, wow, this thing is going. I mean, its hair is on fire pretty much from the time that we leave the dock till the time that we tire back up. And so that part of it's incredibly exciting. You know, the U.S. lost the regatta last time to Team New Zealand, and the New York Yacht Club hasn't had the trophy sitting in the foyer of 44th Street since 1983. So I can assure you we're motivated.
Hi, I'm Wayne Benson. I'm the Director of Manufacturing Product Management at Stratasys. I'm here to talk about our flagship FDM system, the F900. The F900 was developed by Stratasys over 10 years ago and has gone through 3 generations of improvements. These improvements have created a system that is the most versatile, reliable, and repeatable on the market today. The F900 can be used in your additive manufacturing process all the way from early prototyping, functional prototyping, to your end-use parts. The F900 can also be used on your factory floor for production tooling. It's our largest system at 36 by 24 by 36 inches. It's one of the only FDM additive systems on the market today that has a high enough oven temperature to do high-performance thermoplastics at that size. This makes it incredibly versatile. Whether you're doing a full tray of small parts or one large part, the F900 can meet all of your requirements. And print confidence becomes even more critical on large parts. With over 14 material options, the F900 is incredibly versatile. Whether you need basic prototyping with our ASA or high strength with our Nylon 12CF, the F900 can meet many different use cases. You can be assured that you're going to get a dimensionally correct part the first time every time. With the F900, we have the accuracy and repeatability that allow our customers like Lockheed Martin to 3D print parts for their customer NASA to fly into space. With GrabCAD print software, it's incredibly easy to go from CAD to print. The F900 comes standard with MT Connect, so you can collect machine and print data and feed that directly into your existing manufacturing systems. At the end of the day, manufacturers need systems that work. They need to know that they have the reliability to consistently meet their production requirements. The F900 is proven to be the most reliable system on the market today, and the most accurate and the most versatile.
Eckhart has been an industrial manufacturing solutions provider since 1958. Manufacturing is a very, very difficult profession. You're under an extreme amount of pressure to work with a constrained supply base. There are part shortages, there's expedites that are coming in from all over the world. An end customer whose tastes and preferences are changing every day.
Insofar as the shortage of skilled workers are concerned, this is a theme we hear constantly from our customers. We can provide solutions that are not replacing operators, but are making up for the operators that they can't hire. We see additive manufacturing, and specifically the lightweighting aspect of additive manufacturing, to be a great solution we can offer to our customers.
Our customers want proven solutions. They want durable solutions. These tools are being used 60 times an hour for an 8-hour shift, 3 shifts a day, 6-7 days a week.
Eckhart's motto is for the life of your line. Anytime we can replace a historically metal component with a lightweight but equally strong, if not stronger, plastic component, then we believe we have fulfilled exactly the promise to our customers that we've made.
And we feel very, very strongly that 3D printing is really the catalyst. It's the enabler that allows us to work with suppliers to iterate, come up with ideas much faster, to test those ideas, and have a proven solution we can use in manufacturing.
We had to design a pick-and-place robot that had a fairly specific end-of-arm tool setup. With additive manufacturing, we were able to design a couple of different prototypes, print them, try them, and ultimately, with limited time and investment, end up with a bracket for the end-of-arm tool that was exactly what we wanted.
We have developed a lug nut starter tool. Normally the operator would pick up a lug nut and start it one at a time. And this is a job that is prone to lead to repetitive motion injuries for operators. Or they can use this tool that is lightweight and able to be used to start all of the lug nuts on a vehicle at once.
Our big focus today is Industry 4.0, and we believe 3D printing has the potential to truly lead significant transformation in the industrial space. So for us, it's the speed and it's the customization that really ultimately is empowered through the use of 3D printing and through our relationship with Stratasys.
With Stratasys and the engineering grade materials, the nylon 12 with carbon fiber, the Ultem 1010, we are able to produce durable, lasting solutions.
Hi, I'm Jacob Breeder. I'm an application engineer here at Stratasys. Today I'm going to talk about using additive manufacturing to create assembly fixtures on your factory floor. Assembly fixtures are work-holding tools that position parts to ensure proper assembly. Some of the pain points using traditional manufacturing for assembly fixtures are that they're often heavy. They also take a lot of time to set up and take down when you're switching from one operation to the next. And a lot of times they're not ergonomic to the end user. Some of the benefits of using additive manufacturing for creating your assembly fixtures are that often you can reduce the weight of the tool as well as customize the tool for the operator and often reducing lead time. For example, Silaxis, a tier 1 automotive supplier, they provide tooling to the automotive industry. They were able to reduce the weight of one of their automotive assembly fixtures from 150 pounds to less than 50. For another example, Opel, who's a major European auto manufacturer, was able to reduce the lead time of their production tools from weeks to a number of days, as well as reduce the cost up to 90%. Depending on the size of tools that you're looking for, we have a wide range of 3D printers that can meet your needs. For small assembly fixtures, we have our F123 series, all the way up to our F900, which is great for larger tools. Stratasys offers a wide range of 3D printing materials. For most assembly fixtures, ASA and polycarbonate are going to be great options. But for assembly fixtures that require higher strength, stiffness, and durability, we would recommend going with nylon 12 carbon fiber. Stratasys' GrabCAD print software not only allows us to simplify the workflow to go from CAD to part, but we can also use it to reduce the weight while increasing strength and stiffness in critical areas of the tool. To recap, additive manufacturing allows you to create assembly fixturing more efficiently by reducing the cost, time, and weight.
So this is the nylon 12 carbon-filled material. It's the first reinforced FDM composite from Stratasys, offering excellent mechanical strength and a very high stiffness to weight ratio. 3D printing with such a strong, stiff material means that you can overcome many of the restrictions that you'd usually encounter when trying to build prototypes out of composites or metal. Instead of worrying about how you'll shape the metal or how to make the mold, you can now go straight from your design on screen to a fully functional carbon-filled nylon 12 prototype in-house with virtually no limits to your design freedom and creative process. Adding to your ease of use is the dissolvable FDM support material that makes it easy to produce intricate parts such as this without the need for manual and messy support removal. Featuring a carbon fiber length and fill ratio that's optimized for 3D printing, the results are highly functional, detailed parts that can be tested in demanding real-world conditions. Being able to come up with a design, validate it, and then comprehensively test it all on the same day, also provides an extremely powerful competitive advantage. It means companies can deliver better performing products at the same time as compressing lead times and making development costs more predictable. The material is so stiff that it feels like you're trying to bend steel. And yet, it's light and stiff enough to make it efficient for a wide range of manufacturing and tooling applications, where the stiffness of the tool is critical to its function, such as in drill guides, end-of-arm tools, brackets, jigs, fixtures, and metal forming tools. So whether you want to compress your product development cycle with high-performance prototypes, or improve your manufacturing floor efficiency, Stratasys Nylon 12 carbon-filled material is now a very strong and very practical material choice. For more information, please check out the Stratasys website.
The best stories have humble beginnings. Ours starts over 30 years ago. From one man's desire to reinvent the way we make things, our first 3D printer was born. Little did he know that this breakthrough would help shape the future of manufacturing.
Report range status.
Range green.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. Go for main engine start. 1, 0, and lift off.
Today, our pioneering technologies are supporting our partners' ever more ambitious goals. The innovation never stops. Whether it's one part or 1,000, from lifelike prototypes to fully functioning components, we're helping turn complex problems into simple solutions while quietly changing millions of lives.
It's very powerful when you show a family, this is your baby's heart, and this is how I'm going to repair it.
We're constantly questioning, inventing, and reinventing, asking, how can we help our customers turn a great idea into a great success? Pushing boundaries to make every industry become faster, leaner, and smarter. From humble beginnings to giant leaps. Whatever your dream. Make the impossible possible.
My name is Louis Malone, and I am the Technical Director for Champion Motorsport. Champion Motorsport is part of a family of companies that includes the Champion Porsche dealerships here in Pompano Beach, Florida, and the former Champion Racing, powerhouse in the sports car racing community. Our flagship victory being the 24 Hours of Le Mans. So we've had quite a successful racing heritage, and moving over to Champion Motorsport now, we were able to bring all of that race experience and technology over here to improve our product line.
One of our goals for the Porsches is to create more power, and to achieve that we need better breathing. We create parts out of carbon fiber for strength and weight purposes and for better flow. In order to achieve a geometry like this, a hollow tubular part, it's difficult to create a mold that makes that easily. We've experimented with a few other processes. The consistency for the sand cores was a big issue. It was difficult to get the right consistency all the time. It basically needed a magic recipe to get there. The multi-piece molds just could get very complicated to achieve the geometries we wanted to achieve. The soluble cores that Stratasys provided us through the FDM machines make it a lot easier. We can create the design in CAD and bring that design directly into the machine and print out the soluble core. This core can be used as an internal mold to create these carbon fiber parts. And once the carbon fiber is cured, we can melt the mold away and we're left with a final product. Many of the parts we produce are to enable the car to breathe a lot better. And one of the parts we produce is the carbon fiber white pipe. This particular part we have manufactured in the past several ways without an internal mold. And we've also experimented with using the soluble cores. We liked what we saw with the soluble cores. We're getting a much better part that's a much higher quality. We get better surface finish inside and out. So we're actually changing over all of our production to take advantage of the soluble cores.
When you're working with hand-built prototypes, you can throw away 5, 6, 7, 8 of them before you get to something that works the way you want it to work. This way, with the FDM and the soluble cores, that 5 or 6 or 7 parts that you may throw away, you don't have man-hours in sitting there making them. The machine is working while I'm doing something else. Even with high-tech production methods, I mean, we have state-of-the-art equipment to do everything else. But if you made a part that was beautiful on the outside, it wasn't beautiful on the inside. And when you're talking about airflow pieces in a modern turbocharged engine, well, the inside is really all the engine cares about, but the outside is all the customer cares about. Well, with these FDM soluble cores, we're able to produce a piece that looks on the inside as good as it looks on the outside. At the end of the day, the FDM technologies, they save us time, they save us money, they put our people back to work working on our cars, on our product, rather than working on building prototypes and fabricating. There's really no downside to this technology for us.